Hi, I am Arindam Mollik and you all are welcome to my channel Technical Ori. Live with Programming. Now, so we are discussing on this series on that is tree data structure. Okay. Now we are discussing on the what is a basic concept of the what is tree, and then complete binary tree, full binary tree. Then we are discussing on the traversal. Now today we are basically see that how can we generate a tree from the different types of traversals. Like pre-order and in-order are given, we are generating our tree, or post-order and in-order are given, we are generating our tree. How can you do that? We are explaining in today's video. Let's start. Now, things is that, for an example, pre-order and in-order are given, we are generating that tree. Post-order and in-order are given, we are generating our tree. Now, if you ask me, sir, for an example, just only pre-order are given or post-order are given, can we generate the tree? Yes, we generate a tree, no doubt. You generate a tree, but it is not a unique tree. That means multiple trees are possible. It is not a unique tree. But if the pre-order and in-order or post-order and in-order are given, then we generate the unique tree. Means for generating a unique tree, you must have in-order traversal with post or pre-order. You must have in-order traversal must be given on the in-order traversal with pre or post-order traversal. This is an example. That is pre-order and in-order traversal of a tree are given. We are generating the tree. Rule says that what is a rule? In pre-order traversal, if given and in-order traversal is given for generating, we are starting from the pre-order and starting from the left hand side elements. That means leftmost element of the pre-order. Scanning is starting from the left hand side element of the pre-order traversal. Then which element we are selected, this element we are finding on the in-order traversal. That element become the root on the in-order traversal. Then we are finding the what is the left hand side elements. The left hand side elements become the left subtree of the element, means root element, and right hand side element is become the right subtree of the root element. This is the procedure. Okay. Why? That means pre-order, what is the pre-order traversal says? Root left right. So obviously 6 is the root node. As we know, always root is the same. Root is not changing. There is a 3 traversal techniques are present, but is there any no changes in the root? No, root is the one, only one. Root are not changing. So that's why. And in-order traversal, what is in-order traversal says that left, root, right. So root become the middle element. If you are finding the root element, then we are finding the left hand, means left subtree or left child and right child of the root. Yes, that's why this is a procedure. And we are repeating the procedure recursively. Okay, how can I do that? So first of all we see the initial step. Then I show you the repetitive step or recursive step. So we starting. Okay. So now what is the rule that we are starting from the left hand side of the pre-order traversal. First we are scanning the leftmost element of the pre-order traversal. What is the leftmost element of this pre-order traversal? 6. Now, rule says that now we are finding the 6 on this in-order traversal. Now check. Yes, we are finding the 6. So 6 become the root element. Obviously, this is a root. That means root left right. So 6 become the root. So obviously, we are finding the 6 here in order. That means left hand side of the 6 is become the left subtree elements. Obviously, that means left, root, right. That's why 6 become, if 6 is the root, obviously 9, 3, 8, 5 become the, means left hand side elements become the left subtree, and right hand side of the 6, that means 4, 7, 2, 10, 12 is become the right subtree element of the 6. This is simple, we are done. This is the initial step. Okay, this is the initial step. So 6 is become the root now, and 9, 3, 8, 5 become the left hand side elements or left subtree elements, and 4, 7, 2, 10, 12 become the right hand side elements or right subtree of the 6 is the initial step. Now we do the repeating step. Repeat the procedure. Now, so this becomes our initial step. This is our initial step. Okay. Now, just you observe my mouse movement. Okay, this cursor movement. Clear. I try to give us simple way to a discussion, explanation. That's why clear the concept. Now, next. So 6 is already visited. Now we are scanning the next element. What is the next element? 8. So now we are finding the 8. Yes, we are finding. So now every element we are finding, that means 8. Now 8 become, we are finding the 8 on the inner traversal. Yes, we are finding. So now 8 is a root. Now again repeat the procedure. Recursive procedure. What is the recursive procedure? Procedure is, now we are finding, again we are finding the left hand side element and right hand side element. Left subtree, right subtree. This is the thing. So what is the left subtree elements? Means left hand side element 9 and 3. So 9 and 3 become the left subtree of the 8, and this part, that means 5, because 6 is already visited. So 5 become the right subtree elements. Okay. So now come here. 8, what is 8 position? 8 is on the left child, means left subtree of the 6. So 8 is become the left child of the 6. Now, what is the left hand side elements of the 8? 9 and 3. So obviously 9 and 3 become the left subtree elements. What is the right subtree elements? What is the right hand side of the 8? 5. So 5 become the right child of this 8. Right? So it is already visited. Visit again, next, scan the next element, that is 9. Okay. Now find the 9 from the inner traversal. Yes, we are finding. Is there any left hand side element? No. Is there any right hand side element? Yes. What is the elements of the right hand side? What is the elements of the right hand side? That is 3, 8, 5. Okay. Okay. 3, 8, 3, 8, 3, 8. Now 3, 8, 5. Now this 8 and 5 are we already visited. So we are basically on the 9. We have only one element. Only one element is the right part of the 9. That means in the right subtree of the 9 having the only one element, that is 3. This is the here. Now 9 is on the left child, that means left subtree of the 8. So 9 become the left child of the 8. Now what is the right hand element of the 9? 3. So 3 become the right child of the 9. So 9 is visited. Then visit the next, scan the next element, that is 3. 3 is already visited. Next element, that is 5 is visited. Yes, 5 is already visited. Visit the 10. 10. Now we are finding the 10 on the inner traversal. Yes, we are finding. We are finding. Now, what is the left hand side element? These all the left hand side element, but 9, 3, 8, 5, 6 are already visited. So what is the left hand side element of the 10? 4, 7 and 2. What is the right hand side element of the 10? 12. So these 3 elements become the right subtree of this root 10, and 12 become the right subtree of the 10. So now this 10 is on the right hand side, means right subtree of the 6. So 10 become the right child of the 6. So now, so 4, 7, 2 become the left hand, means left subtree elements of the 10. Yes, 4, 7, 2 is the left subtree elements of the 10. And 12 become the right hand side. That means right subtree of the 10. Yes, right child. 12 become the right child of the 10. Now, next is, now we are visit the next element, 4, that is 4. That now 4. Now finding the 4 on the inner traversal. Yes, we are finding. So we are finding the root element. What is the left hand side element? What is the left hand side elements? 9, 3, 8, 5, 6, which are already visited. We are visiting the 9, visiting 3, visiting 8, 5 and 6. Now, so there is a no child of the left part of the 4. That means no left subtree of the 4. but we have a right subtree, that is 7 and 2, because 10 and 12 are already visited. 10 and 12 are already visited. These 10 and 12 are already visited. So 7 and 2 become the right subtree elements of the 4. Yes, right subtree element of the 4. Right subtree of the 4. Then visit the next element, that is 2. 2. Finding the 2 on the inner traversal. Yes, we are finding the 2 in inner traversal. Inner traversal. Left subtree elements. This 9, 3, 8, 5, 6, 4 already visited. We have just one element on the left hand side of 2, that is 7. So 7 become the right subtree element of the root 2, and 10, 12, though it is the elements of the right hand side of the 2, but 10, 12 are already visited. So there is a no right subtree of the 2. So we are up on the resultant. Now finally we get this tree. That means these two become the right child of the 4, and left hand side means left subtree of 2 is 7. That means left child is 7. There is a no right child. So this is become our final tree. Now maybe you have some questions, sir. How can you say it is a actual tree? We check that. Just we take any traversal like pre or in. If you are correct, our result is correct. On the result is same. Obviously our tree is this is a unique tree. So we check that. For an example, we take the like preorder traversal. We check it. Okay. This is our tree, and we have checked the after doing the preorder traversal. Apply the preorder traversal in this tree. Is this result are coming? Then our then this is the unique tree. Okay. This is the final tree. We check. What is the formula? Root left right. Root is 6. Yes. Left. That means is the left subtree. Is the left subtree. Again, do the recursive way. Do the preorder traversal in this case. So in this tree, what is a root? 8. So root. Yes. Left. Left means this left subtree. Again into the preorder traversal here. Root 9. Yes. Root. Left. Is there any left child? No. 9. No. Right. 3. Yes. So left is over. Root, left, right. Right is 5. Yes. 5 is over. So left subtree is completed. Root, left, right. Right means this right subtree of 6. Again do the same procedure preorder traversal here. Root, left, right. What is the root? 10. Yes. Left child. That means this part. Again do the 4 to 7. That is there is a left subtree of the 10. Again do the preorder traversal. That is, what is the root? 4. Yes, 4 is visited. Root left. Is there any left child? No. Right. Again do the preorder traversal here on this 2. Root 2. Yes. Left. Yes, 7. Right. No right child. So root left are over. Right. Root left right. Right. That means 12. Yes. So our result are coming after applying the preorder traversal on this tree. The resultant is coming this. That means this tree, this final tree is our resultant tree or actual unique tree. So this is how can we generate the tree when the preorder and inorder are given. Now we see the generating a tree on the postorder if the postorder and inorder traversal are given. How can you do that? Generating the tree we saw. So this is a given example like a postorder and inorder traversal, both are given. Okay. We are generating the tree. Now rule is that in the postorder traversal we are scanning from the right hand side. That means first rightmost element. In preorder, if there is a preorder, we are starting from the leftmost. In the postorder we are starting from the rightmost. That means right hand side direction. Scanning from the rightmost element of the postorder. Then we are finding that element on the inorder, that is a root element. Then we are finding the leftmost elements, that means left hand side elements and right hand side elements. Left hand side elements become the left subtree of that root, and right hand side element become the right subtree of that root node. This is the procedure. Recursively we are doing. First of all, I like to show you the initial step. Then we are applying I should like to show you the repetitive step or recursive step. Starting. So, post order. What is the rule says that? visit the or scanning the elements from the right hand side, means from rightmost element of the posterior traversal. What is the rightmost element of posterior traversal? That is A. What is a posterior traversal? It is a rule. Left, right, root. That means A become the root. What is the formula for the inner traversal? Left, root, right. As we know, root node are every time same. You do the any types of traversal, but root is only one. So obviously A become the root. Now we are finding the root, this A from the inner traversal. Yes, we find. Left hand side element become the left subtree of the A, means root, and right hand side elements of the become the right subtree of the A. Same way, this A is a root now. Here's a left hand side element. B, F, D, G. These become the left subtree elements. And E, H, C is become the right hand side elements. Become means right subtree elements of the this root A. This is the right subtree of A. Now, so A is visited. Now, next repeat the procedure recursively. Now, next visit the C. Next element is visited. C is visited. C, scanning the C, finding the C on the inner traversal. Yes, you are finding. Is there any right subtree of the means right hand side element of the C? No. But yes, we have a left hand side element. What is this? A is already visited because so we have a just two element. Left hand side element of the C, E and H. So E and H become the left subtree elements of the C. Yes, is left hand side elements. That means left subtree of the C. C is become the root node. E and H is the left subtree elements of the C. Now again, next we are visit the E, finding the E on the inner traversal. Yes, we are finding. But if you are finding the left hand side element of the root E, we are finding just A, but A is already visited. So H and C, now H and C is already visited. So H, the right child of the E is become H. Yes, right child of the E become the H. H become the right child of the E. But if you do the position, observe the position, E is on the left child of C. Yes, E become the left child of C. But H is on the right hand side of the E. That means H become the right child of the E. Now, again visit the H. Yes, already visited. Visit the next element is B. B is visited. We are going to from the right hand side. Okay, B. Yes, we are finding the B. Yes, we are finding the B on the inner traversal. What is the procedure? Repeat the procedure recursively. Is there any left hand side element of B? No, but yes, we have a right hand side element, that is FDG, because A is these are the already visited. So FDG become the right subtree of the B. So B become the root, but B is on the left hand, means left subtree of the A. So B is become the left child of the A. But FDG on the right hand side of the B. That means FDG become the right subtree of the B. Yes. Next. Now, next element is visited, that is scanning. That is D. We are scanning the D, finding the D on the inner traversal. Yes, we are finding. What is the left hand side element of the D? BF. B is already visited. F become the left child of the D. F become the left child of the D. And what is the right child of the D? G, because A is already visited. So right child of the root D, that is G. D become the D is a root now. Left child is F. Yes. And right child become the G. Yes. This is the tree. Now we are checking that is a unique tree. That means this is the tree. Which postorder inner traversal are given? Is this tree or not? We are checking. How? For an example, now we are checking the like inner traversal. Inner says that left, root, right. Now left, that means left subtree. We are do the recursively on the inner traversal. Left. B is a root now. Left. Is there any left child? No. Right. Left, root, right. Left, root. Root is B. Yes, B is B visited. Right. Now this left right subtree, again we do the performing the inner traversal recursively. Root, sorry, left root right, left F, yes, root D, yes, then right G, yes. Now this whole left subtree are visited. Root, that means left root, root is A, yes, right, right means this. Again we performing the inner traversal here. Left, left means this. Again we performing the this tree, this subtree of the left subtree of the C, the inner traversal recursively. Left, is there any left child? No. Root, yes, E. Right, H, yes. Then left is over. Root, C is over. Is there any right child? No. So that means we are performing, finding the inner traversal from here. That means this is the unique tree. So this is the final tree, which post order inner order are given. So this is the way we have, I like to show this. That is how can you generate the tree from the, if the post order in order are given or pre-order and in order are given. I think it is clear up to you that how can you generate a tree from the traversals. Very, very, very important, and keep practicing. It is important for your academics as well as for future aspects. Thanks for watching my video.